Suppose you go ahead and you get a job at a company and you earn $11.50 an hour. The more you work, the more hours you work, the more money you actually earn. This relationship can be written as a function because your earnings, how much you earn or make, depends upon the number of hours. We could say the earnings based on hours is equal to 11.5 times your hours. Or for short, we could say E of H, that's still your earnings based as a function of H. It's 11.5 times H. We would say your earn or your E is the name of your function, while H is what you put into your functions to be able to figure out your earnings. That's what function notation is about. Whatever's on the inside tells you what you're putting into your function. Whatever's on the outside is what you get out once you put that in. So we're going to look at operations of functions. We're going to look at adding, subtracting, multiplying, and dividing functions. We have two functions, f of x, and we have g of x. When we have f of x plus g of x, that means we want to just add our two functions together. So we want to take our red f of x and add it to our blue g of x. And then we want to go ahead and combine our like terms. The only like terms we have here are the squareds, 3 of the x squareds plus 1 more of the x squareds. Then we want to go ahead and subtract our functions. Take our red f of x minus our blue g of x. But here we got to actually distribute through the negative sign to all the parts in the blue. So the red doesn't change here. We distribute the negative through. Changes our signs. And then all we have to do is combine our like terms. And once again, the only like terms we have are the squared ones. And we get a total of 2 of those squared ones. Down below here, we need to go ahead and just multiply them together. So we need to take our red f of x and then multiply it by our blue g of x. Then all we have to do is just go ahead and FOIL them out. Multiply the first terms together and we get a 3x to the 4th. Multiply the inner terms together and we get a 7x cubed. Multiply the outer terms together, we get a negative 3x squared. And then we do our last terms, we get a negative 7x, and we have no like terms combined together. That's our answer. Over here, we're going ahead and we're dividing functions. So we got to take the red f of x divided by the blue g of x. In this case, this is our answer, with the exception is you got to look at what happens when the bottom is 0. Because remember, we can never divide by 0, so we never want to let the bottom be 0. So if you would set the bottom equal to 0 and either factor it or take the 1 over and take your square root, you get x cannot be equal to plus or minus 1. Now, there are times you would be able to go ahead and simplify this fraction. If you factored the top and factored the bottom and they had any common factors, then you could simplify that down. In this case, the only thing you're going to get on the bottom is an x plus 1 and an x minus 1, and that's not going to be any of the factors on the top. Now, for any of you that shop at Kohl's or have parents that shop at Kohl's, Kohl's often has a couple of things going on. You can often get a coupon in the mail. It says you get so much % off your purchase. And if you shop there, you often get what they refer to as Kohl's cash, which is just money they take off the top of your purchase. So suppose you end up having $10 in Kohl's cash and you have a $20 coupon. Or not $20, 20% coupon, so 20% off your price. So if you look at the coupon here, you're really paying for 80% of the item because 20% is being taken off and what's left after 20% is 80%. So the price after the coupon, we could say C of x is 0.8 times x. Then if you're looking at your Kohl's cash just takes $10 off your purchase price. So it's C of x for Kohl's is just your purchase price minus 10. Now, you can typically end up using both of these items when you go ahead and make a purchase. So suppose you initially paid, or when it rang up, was $120. Does the order in which these coupons or these prices, discounts are applied make a difference? Well, let's go ahead and take a look at that. So suppose we do the Kohl's cash followed by the coupon. In other words, we're doing the X minus 10, the Kohl's cash, and we're plugging that in here where we have our coupon. So you got to go your purchase price minus 10, and then taking all that times your 0.8. In other words, we took this X minus 10 and plugged it in here for this X. So when we look at that for $120, we got to go $120 minus our 10, and then we got to multiply it by that 80%. When we do that, we get $88. Is that the same as what happens when we do the coupon first and then do the Kohl's cash afterwards? In other words, in function notation, you're taking your coupon, the C of X right here, and plugging it in for X and the K. So we got to take our 0.8 times X, plug that in over here where we see our X. So we have our 0.8X minus our 10. So when we work this out for $120, we got to go our 120 times our 0.8, get that price, subtract our 10, and we get 86. So it does make a difference. Now, in which one of these do you think the store will actually do? Because they only do one of them. They actually only go ahead and do the first one here. Because from your perspective, you're still getting both coupons, but from the store's perspective, they're still getting more of your money. So it's better for the store to be able to have them go ahead and do the Kohl's cash first, followed by the % off coupon. It's not better for you, but it's better for them. So that was really compositions of functions, where you're taking one function and putting it into another. So whenever you have f of g of x, that means you're putting g of x into f. Or if you have g of f of x, it means you're putting f of x into g. In other words, whatever's on the inside's what you're putting into the outer function. So if we have f of 2, that means you need to go to your function f, and you need to plug in 2 for all your x's. Well, when you do that, you get this here, which does simplify down, and we end up getting 28. F of triangle means you got to go to your function f and replace all your inputs with triangle. F of box means you got to go to your red function here of f, replace all your x's with box. When we're looking at f of g of x, it means we got to go to our f of x and replace all of our x's here with what g of x is, which is an x squared minus 1. So we need to replace this x squared with or this x right here with an x squared minus 1, and this x right here with an x squared minus 1, because that's what's in our parentheses. So our original function for f says 3 times your input squared plus 7 times your input, and that's what we have here. Our input, once again, is what was in the parentheses, so the x squared minus 1. Then we'd have to go ahead and FOIL this out, distribute through our 7, distribute through our 3, and combine all of our like terms. When we're looking at g of 3, we need to take 3 and plug it into our g. So we're going to take our input squared minus 1, so 3 squared minus 1, and simplify that down. G of triangle means you got to go to function g, replace your input with triangle. Same thing with g of box. Go to your function g, replace your input, which is your x, with a box. When we're looking at g of f of x, once again, is just this red thing right here. We now need to go to our function g G, once again, says our input squared minus 1. So I have our input squared minus 1 here. And our inputs, whatever is in the parentheses, which was f, so I got to take that and plug it in for all my x's. Now I'd have to FOIL that out and then multiply it out and subtract 1. The last two are compositions of functions. Now, as we look down below here, we're taking 2, plugging that into G, getting that answer, plugging it into F. So you start from the right side and work left, or you start from the inside and work out. So you got to think of G of 2. So you got to go to G, plug in 2 here, which the G of 2 part in the blue simplifies down to just a 3. So it's just an F of a 3. So that means you got to go and take what you had here from G, which was 3, and plug it into F. Work that out, and we get 48. Similarly over here, G of F of 5. You got to start from the inside out, take 5, plug it into F, simplify that red stuff down. We get 110. Take 110 then and plug it into G, which is input squared minus 1. And we get 12,099. Now, that's not the only way we could have done the last two, but it's a relatively easy way. Since right up here we had figured out f of g of x, we could have just taken our f of g of 2, taken our 2 right here, plugged it into what we had right here, replaced all of our x's here for our answer of f of g of x with 2's, you would have also got 48. Similarly over here, since we had already just figured out down below here in black what g of f of x was, and we were looking for g of f of 5, all we would have had to do is take 5 and plug it in here and simplify it down, and you would have got the same thing.